Hi, this is Mr. Chu, and I give you a special welcome to my study room. If today is your first time, then I want to encourage you to subscribe to this channel for more videos. In my most recent video, I promised to solve quadratic equations using the method of completing of squares. So that is going to be our focus for this study. And before we move on to the examples, I just want to state that the completing of squares method is best used when you have a quadratic equation that cannot be factorized. Let's take some examples now. Our very first question is using the method of completing of squares. Solve 2x squared plus 5x minus 1 equal to 0. Give your answer correct to 3 significant figures. As I said earlier, you see that this equation here clearly cannot be factorized because 2 times negative 1 is negative 2. We can't have two factors of negative 2 that when we add to give us 5. So because of that, completing of squares method becomes the easier option for us. And just as discussed in the video before this one, for us to be able to use the completing of squares method, the first thing we need to do is to make this coefficient to be 1, and that is by dividing through by 2. So that will give us over 2 over 2 over 2 over 2. That will give us x squared plus 5 over 2x minus 1 over 2 equals 0. The next step will be for us to move this constant term to the right. We'll have x squared plus 5 over 2x equals 1 over 2. Yeah. Then the essence of using the completing of squares method is to make this left hand side a perfect square. And to make this a perfect square, we just have to add the square of half of the coefficient of x to this side, and that will make the left hand side a perfect square. And again, like I said in the previous video, to find the half of this is just by multiplying the 5 over 2 by 1/2, and that will give us 515,224. And now we are going to add the square of this to both sides, because whatever we do to the left hand side, we must do the same thing to the right hand side so that we don't change the value of our equation. It means our equation will now become x squared plus 5 over 2x plus 5 over 4, which is a half of 5 over 2, and that is 5 over 4, and that is squared, equals 1 over 2 plus 5 over 4 squared, because whatever we do to the left, we do the same thing to the right. Good. Now that here becomes a perfect square, then to factorize it becomes one of these and one of these squared. That gives us x plus 5 over 4 all squared, and that will be equal to 1 over 2 plus 25 over 16 . To simplify the right hand side further, we are going to have x plus 5 over 4 all squared be equal to, we find LCM, which is 16, 2 going to 16, 8 and 8 times 1 is 8, plus 16 will go into use of 1 times 25 is 25. Right. Then now you have to be thinking of opening these parentheses, and that is by taking the square root of both sides. When we take the square root of this left hand side, we're going to have x plus 5 over 4, because the square root will cancel the square here. Then we come and take plus or minus square root of this plus this is 33 over 16. Now we need to make x a subject. So x becomes, this one will be moves here, become negative 5 over 4 plus or minus square root of 33 over 4, because by the laws of set, the square root of a fraction is the square root of the numerator over square root of the denominator, and the denominator in this case is a perfect square. So square root of 16 will give us 4. That's the 4 we have here. Then to split these to have our two roots, our x becomes negative 5 over 4 plus square root of 33 over 4, or negative 5 over 4 minus square root of 33 over 4. Maybe to simplify further, the LCM is 4, and we are going to have negative 5 plus root 33, or LCM 4 negative 5 minus square root of 33. Yeah, so this is the answer in set form, but our question said we should leave our answer, or we should give our answer correct to 3 significant figures. This means that they want the answer in decimal and not the set form. So we are just going to use a calculator to calculate that. So this is going to give us negative 5 plus square root of 33 over 4. Yeah, and we need a decimal, so we press SD, and that gives us our x to be 0.1861141. I've just decided to write it to 6 decimal places for now, or we change the plus to minus. SD gives us negative 2.686141. Good. I have decided to write my answers to 6 decimal places first, before now I come to the right question, which is to leave our answers to three significant figures. So this is the first significant figure because it's the first non-zero number from the left, second and third. So you're going to have 0 points. So therefore x is like that. X equals 0.186 or negative 2.6869 because it's 2, 1, 2, 3. This is a third significant figure. So negative 2.69, and that becomes our answer to three significant figures. 0.186 or negative 2.69. We take another example. Example 2 is using the method of completing of squares. Solve x squared minus 3x minus 5 equals 0. Give your answer in set form. So here, step 1 has already been dealt with for us already because the coefficient of x squared is 1. So we go on straight to the next step, which is to move the constant term to the right hand side. That will give us x squared minus 3x equals 5. Then we take half of this, negative 3, which is the coefficient of x, and that will be negative 3 times 1 over 2. This is the same as negative 3 over 1. So that will give us negative 3 over 2. So we are going to add the square of this to both sides to make the left hand side a perfect square. Like it as x squared minus 3x plus negative 3 over 2 all squared. Don't forget the negative sign, equals to 5 plus negative 3 over 2 all squared. Then now that this has become a perfect square, we factorize by picking one of these and one of these and squaring both of them together. So that will give us x minus 3 over 2 all squared. So remember, if you forget this negative sign, it will not come here, so your answer will be wrong. Because of that, you have to remember to always carry the coefficient of x with a sign before it so that you don't make any mistake. And that should be equal to 5 plus 9 over 4, because when you square this, it becomes positive now. To simplify the right hand side, we are going to have x minus 3 over 2 all squared equals to, LCM is 4. This is over 1. 1 will go into 4 times 5 is 20. Then this will be 9. We take the square root of both sides. The square root of this one will cancel the square. So we are going to have x minus 3 over 2 be equal to plus or minus the square root of 29 over 4. Now we move this to the right hand side to make x the subject. X becomes 3 over 2 plus or minus square root of 29 over 2, because Square root of 4 will give us 2. Now to split them, x will become 3 over 2 plus square root of 29 over 2, or 3 over 2 minus square root of 29 over 2. To simplify further, x is going to give us 3 plus square root of 29 all over 2, because they have the same denominator, or 3 minus square root of 29 all over 2. Since this question asks us to leave our answer in the set form, this becomes our final answer, because set form means we should leave it in the square root. So this becomes our final answer. Up next are some questions for you to try on your own using the method of completion of squares. All right, nice one there. So this is how we solve quadratic equations using the method of completing of squares. I hope you will try all the questions that just passed and share your answers with me in the comment box if necessary. When you are solving, you have to be careful, especially when the b is negative and you are going to take half of it. You must make sure you carry the negative sign along so that you don't make mistake. You can always verify your answers with the calculator to know whether you are doing the right thing or not. Thank you for making time with me in my study room today, and I hope to see you another time. Don't forget to subscribe if you haven't done that yet. Till we meet again, bye bye.